Hi guys, sorry I couldn't be here today. Hopefully going over last night's homework via video and then giving you some of the examples for 3.3 assists you in moving forward. I'm on page 10 of your workbook, which was last night's homework. Before you left yesterday, we talked about making sure you answered each of the 3 questions from where the intervals are increasing or decreasing or are constant, the max and mins, and then the domain and range. I'm going to quickly go through it. Make sure you're paying attention to detail. Details are really important here, whether you're using parentheses or brackets. This function is increasing anytime you see the lines going up from left to right. It's increasing from -10 to -7. The reason I have -10 as a parentheses or a soft bracket is because -10 is not an endpoint of this part of the function. It's kind of in the center. So it's decreasing, then it's increasing. So really at -10, it's not doing either. So that's why we don't include it. And it's going from -10 to -7. Since -7 is an endpoint, I used the bracket. From -6, endpoint, so I used a bracket, to -2, in the center, so I used a soft bracket. Then again, from 7 to 12. And since that whole thing is increasing, endpoint to endpoint, I used the bracket. That is interval notation, and that's how they asked you to actually write your answers. So that is perfect if that's what you have written. If you decided to use set notation just as a practice, you should have -10 is less than x, which is less than or equal to -7. And remember, less than or greater than is the soft brackets, and then less than or equal to or greater than or equal to are going to be your hard brackets. It is decreasing from -13 to -10. And then again, from -2 to +5. Remember that these values are your x values. You talk about the intervals in terms of your domain values. Number 2, you have a minimum here and here. They're the lowest points on your graph. The minimum is 1. So the actual minimum is 1, and you would have to tell me where it occurs. It occurs at x equals -6, and again at x equals 5. The maximum is 8. That's the highest number, and that occurs when x equals -7. The domain values, unfortunately, we can't just put one interval because there's these gaps here and here. So your domain is in 3 separate intervals, -13 to -7. It is again from -6 to +5, and then again from 7 to 12. And then you can just put a comma in between those. You do use the hard brackets because those are parts of the domain. They are solid dots. The second one's a little bit trickier. We know this to be an exponential function. If you have an exponential function, here's some key hints to kind of keep in mind. Maybe even make yourself a little note over here. Anytime you have an exponential function that is continuous, meaning your points are connected, is not discrete, you are always going to have a domain of -infinity to infinity. It's always going to move all the way from left to right. Your range, however, is always going to have a boundary. And it just depends on what the actual exponential function is. So you're always going to have infinity as one of your 2 parts of the interval. The other part is going to be a number. And we'll definitely get into that more, so don't stress too much yet. We'll practice it. In this case, from left to right, the whole thing is decreasing. Sometimes you'll see them say it's decreasing along the domain. And the domain for continuous exponential function is always -infinity to infinity. So from left to right, there is no minimum. It is approaching 3, so if we come down here, it's getting super close. Remember, though, anytime we looked at the values in the calculator, just kept getting closer to 0 or whatever number. In this case, it's going to get closer and closer to 3, but it's actually never going to touch. And then there is no maximum. Up here, it's going to keep going on forever, so it's approaching infinity. That's called end behavior, and we'll talk about that more today as we move into 3.3. Again, a continuous exponential function. Domain is always going to be -infinity to infinity. The range here is a little tricky because it's almost backwards. It's approaching 3, so that 3 is going to be the lowest value it'll ever be. And notice I didn't use a bracket because it's not ever going to equal 3. And then the range can go all the way up to infinity. This is the last one from the homework. Description of function is increasing from -infinity to -2. So it's going up here from -infinity, which is down here, to 2. Notice that point is part of the function, but again, it's kind of like not really increasing or constant or decreasing at that point. So I just left it as negative infinity to negative 2 with a soft bracket. It's constant from negative 2 to positive 5. And I actually use the hard brackets here because it is at 2, and here it is at 2 again. So it's saying constant, meaning the value of the function did not change. It stayed constant. And it's decreasing from 5 all the way through positive infinity. Remember, these values are representing our x values. The maximum value is 2. That's the highest part, and it occurs on the interval negative 2 to positive 5. Your domain values go all the way from left to right, so negative infinity to positive infinity. And your range, the top number is 2, and it seems to go all the way down and down. So negative infinity for your range is down here, so negative infinity to positive 2. So that is explanation of page 10. You're actually going to go ahead and scoot over to page 13. And your substitute is going to give you a sheet that looks like this to help mark your answers. They have a lot that they want you to tell about each of these functions, so there's certainly not enough room to do everything that they want. So let's look at what the key features they're looking for. They want you to determine if the relationship represents a function, and if so, state the key features of the function. Key features include your intercepts, the intervals where you see increase and decrease, or maybe constant. Relative maximums and minimums, remember we talked about those yesterday. Symmetries, domain and range, and in some cases we'll talk about end behavior. We're going to do 3 or 4 of these right now as part of your notes. And then you're going to have a few that you're going to be responsible for your classwork. So we're actually going to do 1, 2, and 4. We're going to start there, and then you'll have a few on your own. All right, so for number 1, we have 2 straight lines. They are not linear necessarily as a whole, but they do form a function, because if I use my pen for the vertical line test, I never touch more than 1 point at a time. So remember, a function is, and if you had to define this on a test, could you? A function is where every input has one distinct output. And sure enough, it follows along with that because my pen never touches more than 1 point at a time. So for number 1, it is a function. So let's talk about where it's increasing. It's increasing along the graph here. It increases from negative 3 to positive 1. Negative 3 is the input, is the starting point, end point, so that's fine to use as a bracket. And then 1 is for your stopping point, not increasing or decreasing at that point, so we're going to use a parentheses or a soft bracket. In this case, they want you to use interval notation. I have you doing interval and set notation, so you just have to look next to the number of how I want you to write it. So it starts at negative 3. Remember, these are our x values, and goes to 1, and then you put the parentheses. It decreases again, starts at 1 to decrease, and goes all the way to 4. There are no constant intervals. There's none that go straight across, so you can just leave that blank. Maximums occur where the range value is at the highest point. So this is our maximum. And you should go ahead and mark some of this on your graph as you're going. The max value is 4 at the x value of 1. So x equals 1. Here's your minimum, because it's the lowest point on your graph. The minimum is 0 at x equals 4. So some of these, as we move into y-intercept and x-intercept, some of them you're going to kind of have to guess. Technically, we could figure it out, but we're going to just use our estimation powers and get a good idea of where the intercepts are, because some of them you're truly going to have to guess. So this y-intercept is where it touches the y-axis, is just above 3. I would say maybe about 1/5 of the way up, so I'm going to say that the y-intercept is 0, 3.2. You said 3.25, that would be fine. The x-intercept, That one's a little bit more clear. The x-intercept is 4, 0. Domain values, remember those are your x values. They go from left to right and includes those endpoints because they're solid dots. So hard bracket, -3, comma, there's no breaks, the 4, end bracket. Your range values are your y values. The lowest point was here at 0, so bracket 0, the highest value was 4, end bracket. This is non-linear, even though parts of them are lines. As a whole, the function is not linear, but because they're connected, we're going to say that it is continuous. So that's number 1. We're going to look at number 2. Number 2 is, the first thing I want you to do is it a function? Remember the definition of function? Each input has its own distinct output. So if I put my pencil along here, I notice if I was to input 5, I would get this value, but I could also get this value. Remember when we talked about it in terms of like a phone line? If I press 5 and got my mom one day, and 5, the next day I get my ex-boyfriend, that's awkward. It's not a functional phone line. Every input has to have its own distinct output. Even though it's not a function, we can do a little bit with talking about its key features, but whenever it's not a function, you're not going to have much to say. So for number 2, I'm not overly worried about its increasing and decreasing intervals, or there's no constant, but let's talk about the y-intercept. The y-intercept is where it touches the y-axis, which is right here. So my y-intercept is 0, 0. My x-intercept, well, it touches the x-axis at 0, 0 as well. We can also do the domain. The domain, remember, is my x values. So it starts at 0, and then it goes all the way over, and those arrows tell me it keeps going, so it goes to infinity. Infinity is not a distinct number, it just means continuing on, so parentheses. The range values, it's going to keep going up, 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 and down, down, down. So my range is going to be -infinity to infinity. It is not a function. It is not linear. And we really, I don't even know that I want to designate continuous, discontinuous, or discrete because it's just not a function. Technically, because the points are connected, you probably want to say continuous, and that's fine. And that's all you have to do for number 2. We are going to scoot on to number 4. Figure out how to fit all this on here so you can see it all in one. Alright, I made myself a little note here that I wanted to make sure we discussed end behavior, and I included that as part of your explanation in this table, and I didn't have you doing it for all of them, so this is just one way for us to make sure we talk about it. Alright, so here I have a function because every input has its own distinct output, so it is a function. We also know it's discrete because my points are not connected. If I think about what's happening here, it is going down the hill. So there are no increasing intervals. It is decreasing. Again, you're going to kind of have to estimate. They don't do a nice job of giving you exact values. I would say that's what, maybe 0.8. Oh, I'm sorry. This is actually 1, so be careful. This is 0.5. So it's just below 0.5. So it's probably decreasing along 0.4, comma, and then all the way to 4. I'm using interval notation still with those brackets. There are no constant intervals, so I'm leaving that blank. The maximum right here, the maximum value is the y value, 3, at x equals 0.4. The minimum down here, let's see, so this is 0.5. It looks like it's pretty much right in the middle. So the minimum value is 0.25 at 4, x equals y-intercept doesn't look like in our graph. It touches the y-intercept. Maybe we didn't get all of the points, but there's nothing we could say about it. Again, it doesn't seem to touch the x-axis, so we're going to leave those blank. Okay, so this is where domain and range kind of change. My domain, since my points aren't connected, my domain is just specific values of the domain. And this is actually where you almost have to use set notation because you don't have an interval to actually write. So the domain values, you write them in order from least to greatest, and you do like one of those funky little brackets, and you start by writing each of your x values. So I see it as 4/10. There's a point at x is 1, a point at x is 2, a point at x is 3, and a point where x is 4. Range values, again, you're going to have to use specific values, and you got to start with your minimum. So what did we say that was? About 0.25. That's at a half. That's at 1. That's at 2, and that's at 3. And you use the end bracket. It is nonlinear, and it is discrete. So whenever I ask you for end behavior, I'm talking about what do you see happening as x approaches infinity. So you're going to write a sentence for these, and it's always going to start like this. As x approaches infinity, the function appears to approach, and then you're going to have a value. So if you think about what's happening here, like if I was to continue this on, it's probably going to get lower and lower and lower. Remember, with continuous exponential functions, there's going to be a boundary. Your domain is always negative infinity to infinity, and it looks like this would continue up, up, up. So the boundary is going to be down here, and it looks like it approaches 0. Your substitute will make sure you are clear about what all of your tasks are, but I'm going to go ahead and show you on a sticky note what the rest of your day will look like. You are responsible for this by next Wednesday, and the reason I'm saying Wednesday is because I know 8-3 has a field trip Monday, Tuesday. When you come in Wednesday, we're going to wrap up 3.3, and then you will have a quiz next Thursday. Your classwork today, to start with, you're going to do page 11, which is homework from 3.2. You're going to rip it out and turn it in. You are doing this by yourself. You have to write an explicit and recursive formula for each of the tables that are given. Then you're going to go back and continue on with what we just did, lesson 3.3. You're going to do numbers 3, 5, and then 6, 7, 8, and 9. Notice some of these are in set notation, so that's where you're going to use your inequalities. If you're confused with that, write them in interval and get answers, and we'll figure out the set next week. Your homework is page 16. So when you come in next Wednesday, you need to have all this done. This needs to get turned in today. All right, good luck. Sorry again I'm not here. Enjoy your field trip, and I will see you next week.